Hello and welcome to llvm-objcopy-ing, a show where you cannot see me. Okay, that is embarrassing. Let me check what's going on here. Okay, should be better now, hopefully. Let's try it again. Welcome everyone to llvm-objcopy-ing, a show where we learn how to build modern distributed database using nothing more than our bare hands, code editor, like maybe some terminal macros, but like nothing fancy. And I mean, like usually I start kind of like hyping TigerBeetle, saying like, hey, it is implemented in Zig, it doesn't do memory allocation after startup, it recovers from all kinds of disk errors, it uses even number of replicas in a quorum, which is surprising. But today I'm not going to do this, because today we are looking at one of those insane things about TigerBeetle, like, one of those parts which make me stop and ask what, and that is upgrades. So why our upgrades are so awesome in TigerBeetle? Well, because TigerBeetle does upgrades. TigerBeetle does backwards compatibility by just physically smooshing several versions of a TigerBeetle in a single binary. So that's literally what we do in the build system. We build our current version of TigerBeetle. We download an old version of TigerBeetle from GitHub releases, and we fuse them together, and that's why we get a binary which is able to execute either old version of TigerBeetle or a new version of TigerBeetle. Why do we need this? Well, we need this because we want to maintain a critical invariant, that every iteration in the TigerBeetle log of events is executed by exactly one version. So there is a moment where we say, okay, this operation is executed by version 2, and the next one is executed by version 3. So there is a moment where, like, we need to actually jump from one version to the next version, and that means that we need to log both versions around. The next question is, like, why do we require that? Why can't we just, like, maintain backwards compatibility and, like, change TigerBeetle without changing its logic? And the answer there is that TigerBeetle requires not only logical compatibility, but also physical compatibility. We rely on the fact that every data file in the cluster is byte for byte identical. So if we implement an optimization in our LSM tree, which does compaction slightly differently, if it so happens that half of the nodes run this optimization and half of the nodes don't run this optimization, TigerBeetle would break because it relies on physically identical data files for repair and state sync. Okay, so how do we actually do this? We started looking into that last time, but got derailed by a bug, which we've debugged, fixed, and sent a pull request. Okay. Oh dear, I wasn't showing you the pictures. This is horrible. You should have corrected me. So quickly run through the pictures. We smash several versions of TigerBeetle in a single binary, effectively by concatenating that. And we need that because we have an invariant that every version, every operation is executed by a single version, and we have that invariant because we must guarantee that every replica in the cluster has byte for byte identical data file. Okay, so we have this build file which has code for downloading the previous version, and we have this build multi-version utility which takes let me see, which takes current version of TigerBeetle, past version of TigerBeetle, the one we downloaded with GitHub releases, and smushes them all together. Okay, so today we are going to look at this build multi-version, which is, I mean, less than 1,000 lines of code, but it is like one of the most like horrible, scary parts of TigerBeetle, because we aren't actually going to do literally just that. And why we cannot literally concatenate the binaries, well, although the resultant binary would actually run, it will miss metadata. So the thing is, not only we need to pack a bunch of TigerBeetles in a single binary, we also need to make sure that this latest TigerBeetle, that this like oldest TigerBeetle actually is aware that in the same binary there are newer TigerBeetles. So TigerBeetle needs to be able to run and say, hey, I'm TigerBeetle version 10, but I know that in my binary there is also TigerBeetles version 11, 12, and 14, so I can upgrade to any of those versions. So we need to include a bit of metadata in our file, which says, hey, here are like binaries, here are their versions, here are their sizes. So we essentially need to slice our binary file into sections and place a single binary into each section. And well, it so happens that executable file formats like ELF or Mako or portable executable are already organized internally as archives of sections. So we essentially will use sections of an ELF file, sections of a Mako, sections of a portable executable to stuff bonus versions of TigerBeetle. And hopefully your antivirus would not scream in horror upon seeing this. A legitimate program. It is not a virus. It is like very much intentionally working that way. Well, let's see how it works. So we have target. We have a debug release flag, whether we build debug version or release version, which I don't really understand why we need, but well, apparently we need it. We have path to llvm-objcopy, we don't really want to assume that llvm-objcopy is, oh dear, just a moment. I have a giant insect in my room and I need to expunge it before I can continue. Okay, I'm back. The insect is gone. I wasn't eaten alive, so that's good, but it was really scary one. Okay, so we don't really want to rely on llvm-objcopy being in the path. Instead, what we do to make our build hermetic, we just go and download specific objcopy from like the internet, which we can safely do because we also specify the hash of this thing. So kind of like, you know, like don't have dependencies. And if you add dependencies, like include the hashes of the dependencies in your source, because that's the golden rule, the fundamental law of software dependencies. If you depend on something, if you want to be serious about this dependency, you have to include the hash of this dependency inside your source code. Otherwise, you aren't really pinning it down. And well, we do want to pin it down. Okay. Then we have 3 versions of current TigerBeetle. And why we need 3? Well, because if you think about, there is actually one case where a similar concatenation of binaries happens, and that is macOS. On macOS, you know, there is x86 version, which is like no longer really supported, but it still exists and still important. And then there is ARM version. And you could build so-called you could build so-called universal binaries on macOS. And a universal binary means essentially that it has a version of a binary for ARM and a version of a binary for x86, and like it dynamically dispatches it. And it actually works exactly the same way. By stuffing extra binary in the ELF section. And that's why for our multi-version binaries for macOS, we actually kind of like do like a product there. We pack in a single binary multiple versions of TigerBeetle for multiple platforms. Okay, and then we have old TigerBeetle. And again, this old TigerBeetle itself is a multi-version binary. So the logic here is like this. We want to include, say, 4 versions of TigerBeetle with our TigerBeetle. And this TigerBeetle path includes 4 versions. So what we actually want to do, we want to extract those 4 versions from this path version, drop the oldest one, and keep like the 3 latest one and add our on top. Okay, then there is a path specified by the Zig build system telling us where to write the result. And we also pass in temporary directory because again, why would we rely on TMP environment variable, which points to some global world readable, world writable state, while we could use something private to Zig build system. In general, kind of like pass dependencies explicitly as arguments. This is like not hard to do, and it saves a lot of pain down the road. Okay, so some like boilerplate to parse arguments, create allocator or whatnot. Also, we've recently, well, actually, it's not recent code. Okay, so we have. I want to. I want to update to more recent stuff. Is it origin main? Okay, and reload window. Okay, yeah, so we have like now a reload window and it doesn't work. Why is that? Oh, I think because we're using old Zik here, right? Oh, now it's new Zik. Well, why are you not working here? You should be. Oh, okay. Now it's fixed. Yeah. So we have like this slightly reshuffled our namespaces. So now, if you want to parse arguments, you just say standard X flags, and those are your flags. Okay. There is like this temporary directory. We parse our target. Mark is special because we do this like universal binary. So let's see the Windows Linux case, which should be simpler. Okay, and actually I kind of like that really remember what we are doing here. So let's see, we start with modifying TigerBeetle working binary in place. And the first thing we do is that we do deterministic copying. So we used to llvm-objcopy, which could actually take an L file and split it in sections and reassemble it back together. And here I think we actually say source, it should be like target or something. We ask it to like disassemble and reassemble our file in place to make sure that the sections are in deterministic order, and we encode also the checksum of this file, which is, I mean, like, okay, it's not the optimal way to compute the checksum. Like you could actually compute it in Rollin, but well, we don't care because we use arenas here. Okay, so we have presumably here, so we take our current TigerBeetle binary, or we have the deterministic version of it, and we have its checksums. Now, we will write several files. The header, which contains like information about like what versions do we have, the body, the actual versions, and multiversion 0 header. So I think what we also want to do here is that we want to checksum our binaries so that we at runtime can sanity check that what we are executing is indeed what we want to execute, to protect ourselves from software, from disk failures in the executable binary itself. But the trick is, like, we want to add this checksum to the file itself. And like if we add the checksum and then compute the checksum will be different. So we will be computing the checksum with the checksum field zeroed out. So that is probably what is header 0 is doing. Okay, then we go and we write out zeros for this section. And what we are writing is multiversion here. So let's see what actually do we have in this header. Okay, we obviously have a lot of comments which are not super interesting, so I will just go into fold it and like, yeah, non-docs comments are not foldable. Okay, so we have checksum of the header, checksum binary without the header, so presumably that exact thing which we are going to zero out. Checksum for like the current release, the version of its header itself, these are releases max. Like presumably how many releases we could include. What is the current release? What are flags? Okay, the flags for the current version. So whether it is debug or release version and visit. So okay, that's kind of like fun. So imagine that currently the data file is on version 10 and you start a binary. And the binary includes version 10, 11, 12, 13. So of course it starts with 13, then it sees that the data file is 10, and then it restarts into 10. So it can upgrade. But because it already has 13, not only 11 and 12, it could actually either upgrade to 11 or upgrade directly to 13. And that depends on whether there are some protocol changes which require stepwise upgrade. And this is exactly what is controlled by this visit flag. Okay. So we have some information for current releases, and then we have some information for past releases, which is release, checksum, offset size, flags, and extra metadata. And it kind of like bugs me why we have to treat this specially. Like we could just use all the releases there. But well, I guess that is fine. And that is encoded in like struct of array so that we minimize padding on disk. In general, kind of like struct of array becomes even more important when you start writing stuff to disk, because like padding on disk is like really not that useful. Okay. Okay, and we have like zeroed stuff, which is like really we should write these as flat 0. And here as well. Actually, okay. Let's do this. Let's do this cleanup here right away. Flat 0. Zeros. Yeah, this is really not great use of this function. Flat 0. Zeros. This is also flat 0. Zeros. Well, this one has to remain. Okay, I don't like this at all. Okay, do we have something similar in here? Zeros. Flat 0. Zeros. Okay. Let's see if this passes. Is it splat more switch splat. Always clean up things quickly. And let's assign, well, okay, let's assign Federica here. Okay, to what we were trying to run. Okay, we were trying to do build test integration. Okay, and I think I want prominent file errors here. Okay, so this one. Debug false, visit false. What? Okay, so here we need splat at splat. Seems to be working now. So git add edit. Okay, it seems to be working. And let's why aren't okay? Because feds already assigned. Okay. Where we were in build multiversion, so we we zero out that file. Then we tried to build multiversion body, passing object copy, passing TMP path. Wait, I'm not interested in build. Multiversion universal. Okay, and okay, this is like how do I actually fold? How do I fold this entire thing? Like it just doesn't work. Stupid editors. Okay, I don't build. Yeah, we're interested in build multiversion single arch. So okay, so we build multiversion body, passing architecture, past version of TigerBeetle. and sections body, but we don't actually use 0 here as well. Okay, let's see how do we do this. Okay, we read the old version of TigerBeetle. We parse out offsets. Presumably, this is offsets for old version of TigerBeetle. Okay, we get multi-version header from this passed binary. Okay. Then there is some special casing for when we were making multi-versions for the first time. Okay, then what is this thing? I don't like this. Like, this really wants to be something like multi-array list or something like that. But well, okay. So let's see. What do we do here? Can we write this better? We take old current release. macOS, we aren't really interested. So we, okay, so here we do. Okay, so this is a special case for extracting the current release, because like current release is special because it is what's actually executed, and that is essentially like binary without our multi-version section. So MVH it is multi-version header, and MVB is multi-version body. Okay, so that all goes to this thing, alt current. Okay, we flip the executable flag for some reason. Not sure why. We double check that the checksum in the header actually matches the old binary. Okay, that all makes a lot of sense. Check the size. And then we do header past count minus past count. Well, I mean, like, if you subtract past count from past count, I wager that you get 0, but no. So, okay, so we are guaranteed to include one version, and in debug we include only one version. Otherwise, we include 3. So this is like the raw number of past versions. And I guess the newer versions, so the oldest version is the first one. So we need to take past count from the end. Okay, that kind of like makes sense, although it's also kind of like horrible. Okay, and apparently there's some naming scheme where we say that past something is the past version. So okay, for extracting the current version, we were using llvm-objcopy. For extracting past versions, we just go to the raw binary and do this. Okay, so we go into the body, then go to the offsets. Okay, that makes sense. We write these file 777 is 777. Okay, that makes sense. And we say, okay, we have like this release and checksum, and the current release is the last one. Okay, yeah, that makes sense. So we compute the offset, which is some of those things. Do we really need this line? I mean, it like it's better this way. I wish it was possible to like somehow like write this. Oh, can we write this as a one-liner? So if we for like total equals 0, total plus equal s else total. Well, I mean, it would be yeah. Well, no, not good. Like we can't really declare this total, and we sort of need it. Okay, we set this true, and maybe we should already flip it to false, but well, okay. For now, we use true. What is unpacked? I have no idea. Oh, okay. Unpacked is presumably the name of the binary, like the path with the file. Should we just use file descriptor there? Well, I don't know. Okay. Yeah. Okay, so then we create. Wait, what is happening here? Aha, so this I think, okay, this I think is the place where we might be actually creating the concatenated file. So we just go and say, okay, we're going to write in this file like okay, so we read the pass binary and then we write it into a binary with this offset. And how do we compute offset? So current release offset, it's just I don't really understand this. Are we really just concatenating this? Okay, feels mysterious. Then we init it feels like so. Can we write it simpler? Or can we just do this like without init? Like just, hey, please give me like you use it as a builder. Well, and this is unpacked, but what is body file? Options output. So we just write them one by one. Latest release is 1, so the latest release is actually at the very end. Okay, this is okay. This doesn't really make sense to me, but well, we'll see. the version. So okay, so we got our past versions. Oh, okay, right. I get confused. So I was thinking like, that we are creating, so when we were doing this p writes here, I was thinking that like, hey, like we are creating an actual L file and it kind of doesn't make sense. But no, remember, this is only past versions. This doesn't include the actual latest version, which would be like the true L thing which executes. So those we indeed like literally just concatenate all together. And that is what we park in the Elf section. Okay. So, okay, now so this is where like the actual cooking happens. So we use objcopy with deterministic archives, and we add two sections. One is concatenation of all our past versions. And then the zero header. And then we checksum this file. And then we create true header, which now contains the checksum and like everything else we want to do here. Including like current commit hash and whatnot. Checksum the stuff, and then we write the header about. And yeah, okay, so this one is like the true thing, where we remove our zeroed header and replace the true header. And yeah, after this we have our multi-version binary. Okay, but I'm really okay. I'm really quite bugged by that horrible duplication. Can we like use? Yeah, but by this thing basically, it's like it's too much. Can we just say that? Can we just have folding work, please, in this editor? Because I mean, this doesn't make sense that it doesn't fold properly. I bet that in IntelliJ it folds properly. Okay, so can we just have pub and then add self past releases and that is going to be struct of what we are going to add. So we'll assert that self count is less than past releases max. And then we say const index is self count. Then we say self count plus equal 1. And then we say self releases index equals releases next release, and the same for checksum, and then offset, and then size, and then flags, and then git commit, and then release client mean. Okay, that makes sense. And now what do we have in the options? Release, checksum, offset, size, flags, git commit, release client mean. Okay, it's it. And I guess we also want to check. Oh, no, let's update count last. If self count, we want to assert that self releases is, so the latest release, the largest release is the last one. So we want to assert next. Okay, this thing. Okay. I guess we actually want to assert a bunch of things here, like, so next release is not now. And checksum is not now. And offset is not now. And size is not now. Flags might be now. And release client mean is not now. Okay. Verify. That makes sense. So do we have any smartness in releases? Not really. So I think we could just keep this. And like kill this stuff. And then in build multiversion, okay, so this is going to be past releases. Past releases. Assert past releases count equals 0. Okay. So now Okay, we are. Okay. And then we say past release add release past. Okay, I think here I actually would need multi-cursor. Okay. What is offset? Why we are storing offsets? Like sizes would be enough. Like we could have computed offsets. Well, past offsets. Do we use past offset, past size? Well, okay, maybe it makes sense. So offset so far, we take past release offsets. Well, sizes. Okay, how do we call this thing? Well, sizes. Why it doesn't compute? Well, it doesn't matter. Past releases. Oh, maybe because it's past releases. Okay, yeah, it's past releases. Past release, past checksum, offset, past size, past commit. There. You actually white space is also always okay. Well, no. So yeah, you see, like rather than just edit comments saying, hey, this is not passed, I kind of like say that, hey, this is special key. Can we? Okay, but this already feels marginally better. Now we do alt current release offset. Why do we need alt current release offset? Well, because it's not old offset of current release. It's like old current release offset. Okay, so actually this is okay, maybe we actually say that this is past releases size total. Past releases. Okay, we have add, verify checksums, and then size total self. Past releases, 2, so we save our result, we put it 2 equals 0, and we kind of like sizes, self count, size, result plus equals size, return result. And I guess as a sanity check, if self count assert result equals self offsets self count -1 plus self sizes self count -1. Okay. Const. Well, I can't really spell this any more readable than this. Okay. Aristotle, you see, you saw there is like this bug where it didn't update syntax highlighter in the left file when I added Aristotle in the right file. Okay, so now this is past releases Aristotle. Okay, this one. Do we have old current release visit? Current flags. And it should be just current flags, but okay, I'm not going to touch it. Okay, and now add. Okay, let's do this one more time. Okay. And I guess I want to update unpacked at the same time to make sure, like, you know, it's visibly visible that they are parallel arrays. Then we do past releases verify. Okay, release. Well, let's do this 40 past releases count index past releases index sizes offset. And well, is it? Well, no, I don't want to do it this way because before we iterated. So let's iterate here. So let's see past releases, past releases count. Okay, and now we just return past releases. Okay, before we verify, we need to assert that past releases count equal past count plus 1, which is like not really readable, but oh. Okay. Okay, I think we are done. Okay, and let's see where did we break this. Okay, we broke this really quickly. Okay, what do we do in this test? Releases, flags. We really want to okay, what does this test do? From 2, from 5. So we go. Okay, so it is array of structs of arrays. Releases. Advertisable. Okay, so first I want to, I think I want to flip this. So this is going to be tests 2. And yeah, each test is going to be, what is from? Okay. This is quite an unreasonable test. What is advertisable? Okay, so this is for visit thing. And what is expected? Okay, so okay, I guess I maybe get this. So we have releases, which is struct Okay, it's just like releases and flags. Current from, so current from. Okay. It's maybe. See it that way. And then I want to so this is the type of the thing. And the actual thing okay, let's call it a slice. The actual thing is going to be something like this. Releases. So 1 okay, 2 3. Okay, now it sort of makes sense to me. Current 4 from 2 expected. Okay. Let me copy this stuff out. Yeah. Okay, maybe there is like, a better way to do this, like asking LLM to do this, but I kind of like sort of like don't really trust them for this use case. So let's do this manually. I think it shouldn't make take too much time. Because we could use multi-cursor. Who needs large language models when we can multi-cursor, right? Okay, this one is done. Then let's do another one. And when the work is done, it's time to dig another one. Okay. And the final one. And then we'll need just to figure out all the columns to make sure that we can reformat this thing. Okay, and now I have a bug in there somewhere. And why is that? Okay, so I think Okay, that is almost victory. Okay, releases from current, releases from expected. Okay, looks like it releases current from expected. Releases current from expected. Can you make it better? Well, not really. Oh, okay, I grant you that this is a bit more compact, but also kind of like, oh, okay, if we do this, well, actually, okay, it's not that bad. Releases current from expected. Okay. Yeah. Maybe put expected first. What do you think? Well, no, don't want to waste too much time there. Okay, for tests 2, what I want to say is that we have past releases empty, and then for the releases release, we want past releases add release release checksum 0 offset int cast index git commit. This thing, okay, that is a bit too ugly, so let's add some braces in here. Okay. Now we have past releases verify. Offsets are kind of like not entirely correct, but this should be it. Okay. And now we actually could kill this whole thing if only folding was working in VS Code, which it doesn't. Okay. Multi-variant header advertisable. So let's, okay, I'm using like this new terminal thingy I built, and it doesn't really always work good, but sometimes it works. Okay, it works. So let's see test integration. Okay. So this is singular flag git commit min offset. flags. Flags is plural. Okay, same here. Okay, next. Okay, offset. Okay. And actually, like, why are we even passing in an offset here? Because we could compute it, right? Just pass the size. Const offset if index greater than 0, then as 0. Okay. Self sizes at index -1 offsets. Right? Looks reasonable. Well, probably better to do it this way. Okay. So now we don't need to pass out current release offset. And here we don't need to pass this. Hey, it actually is size total now we don't need at all. And let's see in the refi whether we check that so calculate offset sum of sizes. Okay, so we do check this. Okay. Well, I guess const tests. Equal. Okay, here we also don't need to pass offset between. Okay, did we pass size before? Size is push 1, so actually we want to pass size equal 1 here, and we no longer need the index, which feels like all around zig build test. It feels like all around simplification. Let's see if that still works. Okay, it works. I sort of don't believe that it works. Let's see if I change this to 0. Does it break? It doesn't break. What happened here? Okay. Well, it definitely should be tests, but if true, panic. Oh no. This surely will fail, right? Okay. Well, of course we are not testing this. Let's see. Multi-version. Okay, I don't get it. Why? Okay, maybe my terminal. Okay. So now it should. Realizes. Okay, it doesn't even compile. Okay, so we want to flip this all to const. Okay, so release flags. Release flags 0. Release checksum size flags. Release checksum size flags. Flags. Release flags. Okay. See, git commit is singular. Release client mean. What did we have before here in this test? Okay, add is client name colon. Okay, next checksum. Well, sorry, but yeah. We do want to checksum to be different. We really don't like zero checksums. Okay. Status org, and now if we change this to 0, it should fail. Okay, so now let's say unit test multi-version unit test. Good thing to do. And then let's sort. Tests. Okay, so build CI. Okay, oh dear, it's already 6:30. Okay, it was a long one. I guess we kind of accidentally fell into the rabbit hole at the end, but I think it was a good rabbit hole because I think we did simplify this thing a bit, and wow, we learned how we could multi-version binaries because it's really kind of not really complicated, just a lot of code. But the main idea is that you download old binary, extract all the stuff from it to get all the past releases, and then concatenate all the past releases into a single continuous slab, and then build the final binary by using by taking the current release and using llvm-objcopy to insert that pack of old releases as an extra as an extra section. Okay, so now we could. I wonder, is it actually simplifying stuff? I think it does. Simplify a bit by removing bounded arrays. I don't like bounded array type. It really is not good. Get it away a bit on stream and also through threw in removal of bounded arrays, which are one of my least favorite type. Yeah, these exist there. Let me comment this one out. Ouch, because it is an ouch. Let's see if this looks any reasonable. Okay, it does. Okay, folks. So hopefully you enjoyed this deep dive into the guts of our build system and how we cooked multi-version binaries. So next time, I guess we'll switch gears together, all together, and we'll look at the VSR side of this, like the protocol for how we coordinate multi-version upgrades. And then sometime after, we'll actually merge the two for fully working upgrade algorithm. Okay, so see you next week at 5 p.m. UTC live on Twitch. Goodbye.